What if your AI could automatically refine its own output until it meets your quality standards, without you lifting a finger? We'll build a self-improving joke generator that creates a joke, evaluates its quality, and keeps refining it based on feedback until it's actually funny. You'll see how LangGraph's evaluator-optimizer pattern creates a feedback loop where one LLM generates content while another critiques it, automatically iterating toward better results.
Graph state. Class state type dict. Joke, SDR. Topic, SDR. Feedback, SDR. Funny or not, SDR. Schema for structured output to use in evaluation. Class feedback, base model. Grade, literal funny. Not funny equals field. Description equals, decide if the joke is funny or not. Feedback, SDR equals field. Description equals, if the joke is not funny, provide feedback on how to improve it. Augment the LLM with schema for structured output. Evaluator equals LLM with structured output feedback. Nodes. Def LLM call generator state. LLM generates a joke. If state get feedback. MSG equals LLM invoke. Write a joke about state topic, but take into account the feedback. State feedback. LC. MSG equals LLM invoke. Write a joke about state topic. Return joke. MSG content. Def LLM call evaluator state. LLM evaluates the joke. Grade equals evaluator. Invoke grade the joke state joke. Return funny or not. Grade feedback. Grade feedback. Conditional edge function to route back to joke generator or end based upon feedback from the evaluator. Def route joke state. Route back to joke generator or end based upon feedback from the evaluator. If state funny or not equals funny. Return accepted. Elif state funny or not equals not funny. Return rejected plus feedback. Build workflow. Optimizer builder equals state graph state. Add the nodes. Optimizer builder add node. LLM call generator. Optimizer builder add node. LLM call evaluator. Add edges to connect nodes. Optimizer builder add edge start. LLM call generator. Optimizer builder add edge. LLM call generator. LLM call evaluator. Optimizer builder add conditional edges. LLM call evaluator. Root joke. Name returned by root joke. Name of next node to visit. Accepted, end. Rejected plus feedback. LLM call generator. Compile the workflow. Optimizer workflow, optimizer builder. Compile. Show the workflow. Display, image, optimizer workflow, get graph. Draw mermaid PNG. Invoke. State equals optimizer workflow, invoke, topic, cats. Print state joke.
This demonstrates the evaluator-optimizer pattern, a feedback loop where one component generates outputs while another evaluates them against success criteria. The pattern creates an iterative refinement cycle, automatically incorporating feedback until the output meets predefined quality standards. What distinguishes this approach is its ability to handle subjective quality metrics through structured evaluation, rather than relying on rigid acceptance criteria. The workflow separates generation and evaluation concerns into distinct nodes, connected by conditional routing. The generator produces candidate outputs, while the evaluator applies structured criteria to determine acceptance or rejection. When outputs fail evaluation, the system automatically routes back to the generator with specific feedback, creating a closed loop that continues until success. This declarative flow allows complex quality assessment to remain part of the system design without manual intervention. This pattern excels for tasks requiring iterative improvement against subjective standards, like content generation, translation quality, or creative outputs. It reduces manual review cycles by codifying evaluation criteria while maintaining flexibility through natural language feedback. The trade-off is increased computational cost from potential multiple iterations, but this is often justified when output quality directly impacts user experience or downstream processes. Let's break it down.
Hash graph state. Class state type dict. Joke, SDR. Topic, SDR. Feedback, SDR. Funny or not, SDR.
This state type dict defines the workflow's data schema where each node receives and returns a state dictionary containing joke, topic, feedback, and funny or not keys. The state accumulates and updates these fields as the graph executes, starting with just topic, then adding joke after generation, and finally funny or not / feedback after evaluation, before optionally looping back with updated feedback.
Hash schema for structured output to use in evaluation. Class feedback base model. Grade literal funny, not funny equals field. Description equals decide if the joke is funny or not. Feedback SDR equals field. Description equals if the joke is not funny, provide feedback on how to improve it.
This defines a pedantic model for structured joke evaluation. The grade field enforces strict funny not funny classification, while feedback captures improvement suggestions when needed. This schema standardizes the evaluator's output, ensuring consistent machine-readable results for routing decisions.
Hash augment the LLM with schema for structured output. Evaluator equals LLM with structured output feedback.
This configures the LLM to return structured output, matching the feedback schema. By enforcing a strict response format with grade and feedback fields, it eliminates unstructured text parsing and ensures consistent evaluation results for the joke optimization workflow.
Def LLM call generator state. State. LLM generates a joke. If state get feedback, MSG equals LLM invoke.
This is the joke generation node. It checks for existing feedback in the state, enabling iterative improvement. The conditional logic handles both initial joke creation and feedback-driven revisions.
Def LLM call evaluator state. State. LLM evaluates the joke. Grade equals evaluator. Invoke F grade the joke state joke. Return funny or not. Grade feedback. Grade feedback.
This evaluator node uses the structured LLM output to grade jokes. It invokes the evaluator with the current joke, then returns both the binary funny, not funny grade and improvement feedback. The pattern ensures consistent evaluation criteria while maintaining human-readable feedback for iterative improvement.
Hash conditional edge function to route back to joke generator or end based upon feedback from the evaluator. Def route joke state. State. Route back to joke generator or end based upon feedback from the evaluator. If state funny or not equals funny. Return accepted. Elif state funny or not equals not funny. Return rejected plus feedback.
This is the routing logic for the workflow's conditional edge. It examines the evaluator's feedback in the state object, then determines whether to accept the joke or loop back for improvement. The string return values map directly to the workflow's transition rules, creating either an exit path or a feedback loop.
Hash build workflow. Optimizer builder equals state graph. State.
initializes the state machine workflow using LangGraph's state graph. This defines the container for our joke generation and evaluation nodes, with state as the shared data model that passes between nodes. The builder pattern here enables clean, step-by-step construction of the graph before compilation.
Add the nodes. Optimizer builder, add node. LLM call generator, LLM call generator. Optimizer builder, add node. LLM call evaluator, LLM call evaluator.
Registers the two core processing nodes with the workflow builder. The LLM call generator node handles joke creation, while LLM call evaluator manages quality assessment, establishing the two-step processing pipeline that defines this graph's logic flow.
Add edges to connect nodes. Optimizer builder, add edge start, LLM call generator. Optimizer builder, add edge, LLM call generator, LLM call evaluator.
Establishes the initial linear flow. The start point triggers the joke generator, then automatically passes its output to the evaluator. The subsequent conditional routing, handled by add conditional edges, isn't shown here. This snippet only defines the fixed generator right arrow evaluator pipeline.
Optimizer builder, add conditional edges. LLM call evaluator.
This begins defining conditional routing in the workflow. After evaluation, the graph needs to decide whether to accept the joke or loop back for improvement, and this is where that logic gets configured.
Optimizer workflow, optimizer builder, compile.
This compiles the state graph into an executable workflow. The compilation step validates all nodes and edges, ensuring the workflow is properly structured before execution. Without this, the graph remains just a definition, not a runnable process.
Show the workflow. Display, image, optimizer workflow, get graph. Draw mermaid PNG.
This visualizes the workflow as a mermaid diagram, providing a clear graph representation of the state transitions. Essential for debugging complex workflows, it shows how nodes connect and where conditional routing occurs. The PNG output makes it easy to share or document the workflow structure.
Invoke. State equals optimizer workflow, invoke, topic, cats. Print state joke.
This triggers the joke optimization workflow with cats as the initial topic. The invoke method executes the state machine, cycling through joke generation and evaluation until it produces a funny result or hits termination conditions. LangGraph state-driven optimization. This implementation demonstrates a feedback loop pattern where the state object maintains joke generation context, while the evaluator node provides structured grading to iteratively improve outputs. The conditional routing in root joke creates a tight loop that continues until the evaluator marks the joke as funny, which can lead to infinite cycles if the feedback criteria are too strict or ambiguous. State management through typed dict ensures type safety while allowing flexible key value updates between nodes, making it ideal for iterative refinement workflows.
The feedback that improves nothing perfects the cycle.